about blur points and blur universe. This is our new concept, which is different than the idea of fuzzy sets. Well, assume that X, capital X, is a non-empty universe containing certain points or elements. And suppose that there is a function mu from capital X from this universe into the closed interval 0, 1. Hence, for any x in capital X, we may discuss um, this value mu of x. Yes, beta is mu of x, where beta belongs to our interval. So we say that x is a blur point and that capital X is a universe of blur points, or blur universe. And in general, we consider crisp subsets of X. So let us emphasize this fact. Our points are blur, so in some sense they are fuzzy, while our sets are basically crisp. So there are only two possibilities. X belongs to A or X does not belong to A. So our characteristic function of A is not fuzzy, it's crisp. Of course, we may incorporate fuzzy sets into our theory, but not on this initial level, yes? Well, what is important is that our blurriness is objective, contrary to fuzziness. So it doesn't mean that X has certain degree of membership to A. Rather, it has degree of membership to the whole universe. So maybe it would be better to speak about the level of existence of X, or about its level of authenticity, or about its brightness or visibility. And the last two notions are the best, because the whole idea resembles a picture of a night sky filled with stars. So some of the stars are brighter and better visible, while the others are barely visible, yes? And in particular, it's possible that mu of x is zero, so it means that certain element is not visible, like black hole. However, it exists. In this framework, we can consider several properties and operations which are quite natural. So, for example, if we have subset A contained in our universe, then we may consider core of A, which consists of these elements which are completely true, authentic, for which this visibility level is just 1, exactly 1. Then we have V's of A. So these points for which mu of x is strictly greater than 0, so they are visible, but they may be blurred, because blur of A is the set of these elements of A for which mu of x is strictly lesser than 1. And then we have something which we can call alpha beta subset of A, or alpha beta cut of A. These are these elements for which mu of x is in this interval from certain alpha to certain beta, where of course alpha and beta, alpha is greater or equal to 0 and beta lesser or equal to 1. And if our universe is measurable, if it's measurable with space, then we may consider measure of A alpha beta, so the measure of this subset of A for which our points have certain degree of visibility. And if we are interested on the infinite subset of X, then we may use counting measure. So in fact, this would be just cardinality. In case of infinite sets, this cardinality will be just plus infinity, or maybe aleph 0, or any other infinite cardinality. Finally, we have some operations, some basic algebraic operations. Alpha beta union, it means that we prepare union of two sets, but we take only these elements which have this visibility, yes, between alpha and beta, including alpha and beta if this set is closed, but it may be open, of course. The same with intersection, yes, alpha beta intersection of A and B. Here we have standard complement. These are standard complement of alpha beta subset of A. These are all these elements which do not belong to alpha beta A subset. And here we have this, we could say, internal complement. These are these elements of A such that they do not belong to alpha beta subset of A, as you can see here. So their visibility function is from 0 to alpha open and from beta open to 1. Now let us consider some examples of blur spaces. The first one is very simple. It consists of three elements, say BC, and A gets value 0, B gets 1 over 2, so 0.5, yes, 1/2, and C gets 1. So for example, if we have this set A consisting of two elements A, B, then the cardinality of its 0.5 to 1 closed interval subset is just 1, because there is only one element in A which has for which visibility function takes values from 0.5 to 1. This is B, because C does not belong to A. Something similar with B, you may check all these simple calculations. Yes. Here, for example, we have two algebraic operations. Think about this. Here we have intersection of A and B, but we are interested only in these elements for which mu of x is from 0 to 0.5 open on the right side. So in fact, this is just first A intersection B is B, but we are interested only in these elements. So because B is exactly 0.5, its value, so the whole intersection becomes empty. Other examples. Here we have 9 elements from A to I. And as you can see, mu of A is 1 over 8, mu of B is 2 over 8, mu of C is 3 over 8, and so on and so on. Finally, mu of H is 1, and mu of I is arbitrarily 0. And you may check all these calculations and observations which are here, yes. Interval, blur intersection, and blur union, yes. So you may stop here and check if these calculations are okay. In case of this universe, natural numbers from 0 to 10, we may think that mu of n may be like 1 over n when n is greater than 0, and 0 when n is 0. Here our universe consists of all natural numbers, and we propose this function 1 over nth root of n when n is greater than 0, and 0 when n is 0. Yes. We may consider the core of the whole universe, and in this case it consists of only one number, namely 1, which takes value 1 according to this function. You may check that the last statement is true, that both these alpha beta subsets of A have cardinality plus infinity. Consider this universe from 1 to plus infinity, and this is our visibility function, minus 1 over x plus 1. So for example, we may calculate integral of, let's say, x squared between 1 and 10, but with the additional assumption that we are interested only in these points, for which mu of x takes values from 0.5 to 1. So in fact, it means that we should calculate integral from 2 to 10 x squared dx, yes. This is something similar. Now our visibility or membership function is absolute value of sinus of x. And consider this subset from 0 to pi, and then you see that core of this subset, core of A, is pi over 2, that this set of visible elements consists is from 0 to pi, but open on the left and on the right, and blur of A is like this. And then you may study this picture below and this calculation here. Why is that so? That integral of x squared dx from 0 to 2 pi, but with the assumption that we're interested only in these points which satisfy mu of x from 0.5 to 1, why is this equal to this sum of two integrals? And I think that this picture may be helpful. In the next video, we shall see other examples of these spaces, and we will discuss some basic algebraic properties of these operations. It seems that they do not form typical Boolean algebra, that some of their properties are not so obvious, and that they are rather weak. So thank you very much, and keep waiting for the next video on our channel. Thank you very much.